Hi friends, we're going to talk about our transformations quiz from Friday. So if you have your transformations cheat sheet handy, you might want to have access to it. Looking at number 1, it says use the table to translate the pre-image 3 units to the right and 5 units down to find the new coordinates of the image. So our original coordinates are here. I'm going to use a different color. I'm going to use blue so we can see this a little easier. And we need to find the new coordinates. So if we're translating, remember we're just moving the shape. We're not changing its size or shape. So as an answer to question A, are the image, pre-image and image congruent or similar? We know they're going to be congruent because we're not changing their size or shape. If I'm moving the pre-image 3 units to the right, that's x plus 3. And if I'm going 5 units down, I know that's y minus 5. So when I do that, that's like saying negative 2 plus 3 and 5 minus 5, 0 plus 3, and 1 minus 5, and then 4 plus 3, and negative 1 minus 5. So my new coordinates for A prime would be 1 and 0, 3, and negative 4, and then lastly 7, and negative 6. Looking at number 2, it says a single transformation was applied to the gray triangle to create the white triangle. Circle the correct rotation. Okay, so I see that this has been moved to the right and it's been rotated 90 degrees clockwise. Remember, if we're moving clockwise, we're moving in the right direction. If we're going counterclockwise, we're moving to the left. Are the gray and white triangles congruent or similar? Well, we didn't change their size or shape. All we did was change their location. So they are congruent. Looking at number 3, it says quadrilateral bike is shown on the coordinate grid below. The quadrilateral is dilated with a scale factor of 2/3. Sketch quadrilateral bike after the transformation. Okay, so I'm going to rewrite my coordinates. E, which is negative 6 and 3. A, B, C, B, 3 and 0. K, negative 6, negative 3, and then I, which is 3 and negative 6. And so now my new coordinates for E prime, if I dilate by 2/3, 2/3 is smaller than 1, so I know that this is going to be a reduction. Anything with a scale factor of less than 1 is a reduction. So now I'm going to multiply this 2/3 times each part of my coordinate times x and y. So 2/3 times negative 6 is negative 4. And then 2/3 times 3 is 2. For B prime, remember that prime means the new coordinates. 2/3 times 3 is 2, and then 2/3 times 0 is 0. For K prime, 2/3 times negative 6 is negative 4, and then 2/3 times negative 3 is negative 2. And then lastly, I, 2/3 times 3 is 2, and 2/3 times negative 6 is negative 4. All right, so let's go ahead and plot this. These are my new. So E prime is negative 4, positive 2. B prime is 2 and 0. K prime is -4, -2. And then I prime is 2, -4. So I'm going to draw, connect my dots, and there we go. There's the new figure. A says our quadrilateral bike and the new image congruent are similar. Well, we changed their shape. We made it smaller, so they're similar figures. And because we made it smaller, this is an example of a reduction. Number 4 says triangle KMG is rotated around a point, then reflected over a line as shown to create triangle ABC. Okay, these can be really tricky. So when you look at this shape, notice that KG is long, even though technically it's shorter. It looks longer, and MG is shorter. So when I rotate this triangle, MG, this is the same as MG, and this side is the same as KG. If you notice, this 90-degree angle here and this angle, 32 degrees, is in between my 10.6 inch side and my 9 inch side. So on this triangle, my 10.6 inch side is here and my 9 inch side is here. So I know that this has to be my 32-degree angle, and then my X has to be my 58-degree angle. So the value of X here is 58 degrees, because this is in between my 5.6 angle and my 5.6 side and my 10.6 side, and because 5.6 is KG and KG is the same as AB, my length of AB is 5.6 inches. Okay, looking at number 5, it says triangle XYZ is shown on the coordinate grid below. The triangle is reflected over the y-axis. Sketch triangle XYZ after the transformation. Okay, so when we reflect over the y-axis, my XY coordinates turn into -X and then Y. So my original coordinates for X are 3 and -3. For Y, 6, -7. For Z, 3 and -7. So my new coordinates for X prime are going to be -3, -3. For Y prime, -6, -7. And then for Z prime, -3, -7. So when I go to plot these, I'm going to go -3, -3. -6, -7. +3, -7. Oh, sorry. Mr. Wood's bad. That's -3, -7. There we go. Okay, and there's our new triangle. Are the pre-image and image congruent or similar figures? Well, all we did was reflect them, so they are congruent. We didn't change their size or shape. For number 6, it says, what two transformations would you apply to triangle ABC to get triangle DEF? This is a multiple choice question. Okay, I'm going to write my original coordinates for A, for B, and for C. So for A, it's 2 and 5. For B, it's 2 and 2. And then for C, it's 5 and 2. Okay, now my A prime, B prime, and C prime. Let's look at A to start. Reflection over the y-axis. Okay, so when I reflect in the y-axis, I know that my x becomes negative and y stays the same. So this is going to become -2, +5, -2, +2, -5, +2, which should move my triangle. So -2, +5, -2, +2, -5, +2. Like that. Okay, now let's use red. It says a translation of down 7. Okay, so from here, if we translate down 7, remember up and down is my y coordinate, left to right is my x coordinate. So now for A, double prime, B, double prime, C, double prime. For A double prime, if I'm going down 7 units, my x is going to stay the same, but I'm going to subtract 7 from my y, so it'll be y minus 7. So 5 minus 7 is -2. -2 stays the same. 2. Yes. 2 minus 7 is -5. And then -5 stays the same. 2 minus 7 again is -5. Okay, so let's see where this lands us. So now -2, -2, -2, -5, -5, -5. It's a perfect match. So because those transformations all fit for triangle DFE, I know that choice A is my correct answer. Lucky us, we don't have to go through all 3 compositions. Are they congruent or similar? Well, all I did was reflect and then translate. I didn't change their size or shape, so they are congruent. Okay, lastly, it says classify the following equations as linear or nonlinear. Remember my rules, no exponents. They're not my rules. I say that like I own them. They're definitely not my rules. They're just the general rules for linear equations. No exponents, y equals mx plus b, and no x in the denominator. Okay, so this one looks innocent enough, but when I actually go to solve it, I end up getting y equals x squared minus 3x when I distribute. Because of this, this is nonlinear. This is fine. I can rewrite it in this format, so this is linear. And this has an exponent, and because of that exponent, this is nonlinear. So only one of those equations is linear. Good job, friends.